Hello everyone, and welcome to NSTA Web Seminars, where you can find live interactive learning at your desktop. Today's seminar is titled Chemistry Rocks, Resources for National Chemistry Week, the Classroom and Beyond. Our presenters are Michael Tennyson and Erica K. Jacobson. My name is Ruth Hudson, and I will be moderating today's program. And now I'd like to introduce our presenters. Erica Jacobson is a consultant for the ACS Chem Club and blogs for the JCE ChemEd Exchange. She is a former pre-college editor for the Journal of Chemical Education. Michael Tennyson is a retired high school chemistry teacher and a former associate director of the ACS Education Division. I'll turn the program over to you, Michael.
All right, thanks a lot, Ruth. It's a pleasure to be here to talk to you about National Chemistry Week and resources that you might be able to use either in your classroom or in outreach for National Chemistry Week or in a broad range of different formal and informal settings that you might have for your own situation. We're going to start today with a quiz. I know this maybe isn't the best educational policy, but the good news is it's not going to be graded, and even better news is that you have a really good chance of getting at least 50% of the questions right. So here are the two questions. First is, do you know what your month your birthday is in? And then the second question is, what is your birthstone? So if you know your birthday and your birthstone, put a check mark, and if you know your birthday but don't know the birthstone, put an X in that month. Let me turn it back over to Ruth just briefly. It looks like everybody has this figured out, but she can give us an update about anybody who's just joining about how to make their mark from the clip art.
Sounds great. Thanks so much, Michael. So we're going to use the clip art to respond, and many of you guys are doing a great job doing that. It's a two-part question. Do you know the month that you were born? Hopefully you do. And do you know what your birthstone is? So if you know your birth month, place an X, but not if you know your birthstone. And then if you know your birthstone and your birth month, put a check mark and put it in the correct month. I'll allow for about 10 more seconds of marking, and then I'm going to turn the clip art off so that we can turn the program off to turn the program back to Michael. So you've got about 5 more seconds. All right, I'm going to disable the clip art, and it's all yours, Mike.
Thanks, Ruth. Amazing results. It looks like almost all of us have a pretty good idea what our birthstone is. So let's check our work. So here are the birthstones. Although I have to admit, there are not just one set of birthstones. There are a number of different stones that have been associated with this traditionally. And it's kind of interesting that so many of us do know this. There's a historical belief that there are some powers that are associated with crystals, and it's kind of an anachronism that we maybe would put any kind of credence towards something like a crystal having any kind of control or representation of what our personalities are, or any kind of therapeutic effects. But nevertheless, it is something that is well ingrained in our society, as our polls just shown. It's also curious that we don't have a birth food or a birth gas or a birth fish. So what is it about crystals that have this allure to us? Well, I think part of the answer is that crystals are a little bit different deal than most of the kinds of matter that we encounter. It doesn't take too much to convince anyone that crystals and gems are cut from a different kind of mystical cloth, that their structure and their luster, and especially when they're faceted, their brilliance are attractive to us. There's no getting around that. And I think that that is part of the attraction for us using them as symbols of our married status or giving them as friendship, all kinds of ways that we use gems in different ways. Beyond that, I think that they're a good window into why our topic is timely today. The whole idea that chemistry rocks has to do with some of the issues around how we incorporate topics in geology into our normal everyday curriculum in chemistry, and what kind of special place it has for us in our normal curriculum. And hopefully over the course of the presentation you'll be able to get a good idea about some of the ways we can show how chemistry works in our everyday lives in the context of geology. In terms of the National Chemistry Week, we're going to talk about a number of resources that are provided this year for the 30th anniversary of National Chemistry Week. The goal of National Chemistry Week is to try to help promote chemistry in people's everyday lives, and especially to promote an understanding of chemistry. And for ACS, one of the biggest themes in all of our curriculum materials has been explaining how chemistry works in everyday life. I think most of us are very adept at talking about the theoretical and content basis for chemistry and how it works, but finding those nuggets about where chemistry can be applied and how it works in everyday life is always a challenge. So this is one product that was new this year. It was a NCW-themed calendar that features great photos of each of the birthstones for each month, and then a description of how they, what their history is, where their names come from, and some of those sorts of things. Each month talks about at least one example of the birthstones. I know in my case the birthstone is amethyst, which was named for the ancient Greek amestustos, which has the meaning of not intoxicated. And the lore around amethysts were that if you wore one of the amethyst birthstones, you would be immune from being intoxicated by alcohol. I don't know what everybody's experience is. It hasn't always worked in my case, but nevertheless, I guess it's a noble effort to try to achieve. As it says in this is a limited edition, and we just recently found out from folks at NCW that it has sold out. So unfortunately, there is information in the bibliography that does give information about the source of where you could buy it, but that appears to be no longer available. So I guess the best effort would be to try to find a colleague who maybe purchased one, or maybe somebody at your local section purchased a supply that you might be able to access, because it definitely is a great resource to be looking at. I just wanted to focus on a couple of different items with gemstones. This is a chart from the folks at Compound Chemistry. And if you don't know them, they're really a wonderful resource. It's a fellow from England who's done a number of these infographics on topics in chemistry. And one of the best things about it is that they are copyright enabled for you to use in your classroom as long as it is for an educational purpose. He has a number of different ones that are all just brilliant, and they do a lot of presentation about the theme that we talked about, the whole idea of explaining common chemical occurrences that happen in everyday life, but he gives a good technical background in a very visual and striking way. So this particular infographic has 20 or so gems, and he gets into the specific formulas and characteristics and sort of explains where the colors actually come from for these various gems. I think it's something that could be of interest for kids in the classroom, or if you're doing an informal event that centers around geochemistry or geology, gems and rocks and minerals. It's definitely a nice resource that I'm sure kids would like to take a look at. But I'd like to focus on one of these because there's an interesting story in the bottom line in this gem called Alexandrite. It has sort of a crazy story. It's a color-changing crystal, which is rather novel in the world of gems and mineralogy. It's a variety of chrysoberyl that has the elements beryllium, aluminum, and oxygen, which change color from green or blue-green to a reddish color depending on the kind of light that it's exposed to. It turns out that white light is not created equal under every circumstance. Just like you could think of a lot of different numbers to add up to the number 100, there are different wavelengths that can be used to compose white light. And it turns out that sunlight and incandescent light are slightly different in the way that they comprise what is substantially white light. Alexandrite, because of the nature of the crystal structure and a little bit of chromium ion that's been that is added naturally into the crystals, it absorbs in the visible spectrum around 400 nanometers in the violet range and around 600 nanometers in the yellow range. That means it has low absorbance and relatively high transmission in the blue-green, which is 470 to 520 or so, and in the red range of the spectrum, which is somewhat greater than 650 nanometers. So under daylight, Alexandrite tends to absorb the yellow and violet, but since more green and blue light are transmitted, and daylight has a bit more of that end of the spectrum in its combination, it tends to be in the green range of colors as we observe it. And then for incandescent light, it's a slightly different mix. It still absorbs in the same ranges, but since incandescent light is stronger in the red range, then it tends to look more in a reddish color. So there's no saying that with Alexandrite that says emerald by day, ruby by night, which I think has a lot of lessons in terms of application of the visible spectrum and the whole idea of transmittance and absorption, and sort of a novel feature for this particular gem in its history. In the resources in the bibliography, there's a nice blog by Kenneth Hansen from Florida State University that explains this. It has some nice charts with the absorption spectra, and you can get a better idea of how all of this works if you're interested in using this in your classroom for some sort of example. All right, so I'll turn it back over to Ruth to see if you have any particular questions so far about our presentation.
Thank you so much, Michael. So if you have any questions for the presenters right now, please type them into the chat window, and I'll read them to them, and they can answer those questions. We have time right now for 2 questions from the audience. And so while I'm doing that, I'm going to scroll down and see if we have anyone typing. Looks like we have a couple people typing, so I'll just wait and give you some time to type. And I'll just take the first 2 questions. But don't worry, if your questions are typed, there will be some other times that we can also answer those questions. And Erica does make a good point that you will actually have links in the bibliography of the collection at the end of the web seminar. So they will include all those links. So it still looks like we have some people that are typing. Oh, okay. So Sally says that Garnet is her school's mascot. Can you tell her something cool about Garnet? And I'll turn it over to you, Michael. Just remember to press on the talk button of your microphone so we can hear you.
Well, first of all, I think that's impressive that you have a mascot that's named after a chemical substance. That's very cool. I'm not a great expert in this. As far as I recall, garnet is very, very high in the hardness scale. It has a high Moore level. and it's used in abrasives. A lot of times they're ground, not quite as good as diamond, but it is used for different abrasive discs and sandpaper, and apparently works very, very well for that.
All right, thank you very much, Michael. Do we have another question for our presenters? Marta added some interesting things into the chat too. She says, how is ACS helping chem teachers to understand the most common minerals of the crust, the silicates, and then how they react? Sorry, that was Martin. Would you mind answering that, Michael?
We have a number of resources for helping in curriculum in the classroom. I guess one of our primary ones is ChemCom, our textbook that does have a good section on various physical nature of different kinds of matter. And the other one I might suggest is Chem Matters magazine. Chem Matters is published 4 times a year, and we have a wide variety of articles that we offer. It covers the whole gamut of various interactions of kids with chemistry and how chemistry impacts us in our everyday life. So I guess one thing I might suggest is looking at the comprehensive index for Chem Matters to see if there's something that specifically addresses your question about silicates.
All right, thank you so much, Michael. That's all the time right now we have for questions, so hold on to your questions, and we'll have another break a little bit later in the web seminar. So I'll go ahead and turn it back over to you, Michael.
Thanks again, Ruth. Another primary resource for National Chemistry Week is a publication that's done annually called Celebrating Chemistry. It's designed for basically ages 4 to 6, but a lot of the articles are appropriate for junior high or high school, and it's appropriate for a wide range of different presentations. I know that for all of you in the audience, there are a range of places where you might make use of these materials during your National Chemistry Week celebrations. It may be that you're doing something in your classroom. It may be that you have a chem club and you're going to do some sort of outreach activity, either in a public event like a mall event or at a back-to-school night. Some teachers take their own students in high school down to elementary schools and do special presentations for elementary classrooms. So in all of those, I think that the Celebrating Chemistry is a nice resource for potential activities and articles and other resources that you might be able to use. The articles are very informative, and they're always about the central theme for National Chemistry Week. The Mega Mole career interview is an interview done by one of our mascots that talks to somebody who's working in this particular field. And there's also puzzles and games that can be applied for either using in a classroom setting or one of those outreach kinds of activities. Here's some examples of some of the articles and activities that are in this particular issue for the 30th anniversary. There's a nice article that talks about the general nature of rocks and minerals and gemstones that does a good explanation about what they are and how they're used and significance in our lives. The MOLIDS is a puzzle activity that is very nice and sort of simple activities, but a good way to help kids relate by giving them something to do that isn't terribly technical. And then there are activities that can be used either in a group setting or a classroom setting or one of those outreach activities that I mentioned. And this is one that I thought was very, very nice. It's something that I think is high interest for kids and pretty dramatic in the presentation of it. It's doing the formation of crystals, watching the crystal formations from Epsom salts in a very controlled setting. I think one of the things about crystals that always amazes me is the whole idea that they are a direct reflection of the atomic nature of matter. If we got thrust back into caveman times and had to try to convince a caveman that atoms exist. I think this is one of the examples that I would take with me, because the only way that a crystal has its brilliant and interesting structure on a macroscopic scale is through the careful stacking and interaction of the attractions of atoms one by one as they go from a liquid state to a solid state. And to me, that's both magical and also a good lesson to be able to give to kids about the marvel of our natural world and how it all works. And especially when we see crystals that are relatively pure, knowing that those crystals have to all basically be in place one by one. There can't be any layers that are at odd angles to each other. There can't be contaminants. It gets down to a perfection of materials that I think is rather awe-inspiring. I think one of the most marvelous pieces of nature I've ever seen in my life is at the National Museum of Natural History. There's a 12-inch quartz globe that is perfect. You don't see a single inclusion or flaw. It's just a miraculous piece, and to think that that formed just out in nature all on its own with the crystallization process, it's just awe-inspiring for me. In this particular exercise, it's really very straightforward. You make a saturated solution of Epsom salts, which is magnesium sulfate, and then coat that on a glass surface, something like a microscope slide with using a cotton ball. And then it's allowed to sit for just a few minutes, and students are given a magnifying lens. And through the process of this, you can actually see the crystal structure begin to grow. Just amazing. I think it's one of those popular activities where kids have a lot of oohing and eyeing by just the virtue of the fact that these things grow as though they were alive right beneath their eyes. So a really nice activity for kids to do. There's a second activity that's also in celebrating chemistry, and in that one the students use colored borax crystals that have had a dye added to them, and they allow that to dry and crystallize on pipe cleaners that are bent in different formations. So it takes a little bit longer, but the result is very remarkable and entertaining. I think very satisfactory for kids to do something that they've grown and they've made themselves. So it can even be kind of artistic. So another activity you might be able to do. And again, I think both of these are appropriate for a wide range of ages and a wide range of applications, places where you might want to do them. On sort of a different scale, aiming more at maybe a high school level and something to do with the next generation science standards. It's the whole idea of making claims. I know argumentation is one of the levels for the next generation science standards. The whole idea of having some issue that where a claim can be argued with evidence for or against, and the whole idea of using evidence to support a claim or not. So in this case, it is the claim that Himalayan salt lamps are improve your health if they're in the same room as you are. And there are a lot of claims about how they do this, ranging from absorbing pollutants in the air to maybe giving off some sort of ion, negative ions or positive ions, in a way that has some positive health effect. There's a lot of evidence that it has investigated Himalayan salt lamps, and there's no good documentation that they do anything that they're purported to do. They're very nice to look at. They're a pleasing light. But I think one of our roles as science teachers is to distinguish between fact and myth. And to not go beyond what can be proven in terms of the evidence. There's a really nice activity from an article that was posted online by ACS chemist John Malin that really goes through rather deliberately the claims that are made about the actions of these salt lamps. And he talks about some of the physical characteristics that dispute the idea that they could be as they are. One of the ideas is the whole idea that ions would be emitted from putting a light bulb inside one of these lamps. Salt doesn't begin to dissociate until about 1500 degrees Fahrenheit, and that's well below the temperature that could be generated by a 15-watt light bulb that's typically used to illuminate these things. And his explanation goes into even greater detail about the physical nature, the characteristic properties of salt, and why it would be very difficult for it to do the things that are claimed for it. So again, the encouragement is that maybe you could use this kind of activity if in your classroom you are tasked with the idea of doing argumentation as one of the science processes. I think it would be a fun idea to examine, because there's no doubt, and I've seen this in the chat room, a lot of people have these, and they may very well have seen the information that makes these claims for them. So here's another poll. This is feedback for both you and for the presenters. We've presented some ideas about where geology topics could be included in your curriculum. The content areas have been some of the characteristic properties of matter, structure of solids as they relate to crystals, the idea of chemical formulas and how they relate to the nature. We talked about physical spectrum and how that can interact with matter, and a bit about the nature of light and color. So are these things that you study, and are any of these resources helpful in terms of substitutes or additions to your current curriculum? So it looks like you're well underway on this. I will turn it back over to Ruth just in case anybody came in late about using the clip art.
Thank you so much, Michael. So if you came in late and you don't remember how to use the clip art, it is the mountain and the moon symbol that's at the bottom of the toolbar that you see on the left side of the slideshow. And we would prefer that you pick something from the common symbols choices. There's a lot of them, and just go ahead and mark and respond to these different questions. Do your students currently study any of the topics that Michael has listed? And are there any resources presented that have attractive substitutes or additions to your current curriculum? I'll give you about 5 more seconds to do some marking, because it looks like people are still placing them, and then I'll lock the responses and turn everything over to Michael. All right, I'm going to go ahead and lock the clip art, and that'll allow everything placed. And Michael, it's all yours.
Thanks, Ruth. Well, that's terrific. It looks like great results in the poll. Lots of you are teaching these kinds of topics, and you're finding some things that might be useful to you as additions or substitutes for your curriculum. Very good to hear. So we're going to pause for another question or two, and again, I'll turn it back to Ruth.
All right, thank you, Michael. If you have any questions, please type them in the chat now. I see several people that are typing away, so we'll just go ahead and give them some time to type. It takes some people a little bit longer. Oh, yeah, and Kitty wants to thank us for the ornament link. That is actually a pretty great little activity to do with students. They really like that, and I think it really shows crystals and how they form. So as I scroll down and look, it appears that that we don't have anyone currently. Oh, here we go. Alicia wants to know, can we be provided with the article that debates the benefits of salt lamps. I'm going to turn off my mic, and Michael, would you like to respond to that?
Yes, Alicia. In the bibliography, I indexed one excellent article that was featuring the ACS chemist John Malin, who's an expert in the whole idea of salts and sort of reasonable application of science. I think you'll find it as a good basis for this. And beyond that, I think that there are a number of articles that are on the web that I found when I was doing my research that can come up in the same sort of search. So I think there's lots and lots of stuff, both for and against the idea of using the salt lamps.
All right, thank you so much, Michael. And Alicia, I will post that collection at the end of this web seminar so that you can have that. Are there any other questions? If so, go ahead and type those in the chat window right now. I see a couple people typing, so I'm going to go ahead and wait just a minute and see if they have a question or if they're just making a comment. Looks like people are still typing. Oh, so Sherry does have another idea that we could use. If it doesn't look like we have any other questions, so Michael, I'm going to go ahead and turn it over to you, and you can go ahead and continue.
Thanks, Ruth. That ends my first section of this, so I'm going to turn it over to Erica for the next few slides.
Thanks, Michael. You've really shared some great resources so far, and with this slide, I'd like to offer a chance to kind of continue the conversation with us even after the webinar is over. And if you are on Twitter, you can go to follow the ACS Chem Club's account because we'll be tweeting about this and continuing, or you could do some searches for some of the hashtags we've been using. As Michael mentioned, it is the 30th year anniversary of NCW, so one of those that you're going to find some tweets there is the hashtag NCW 30 years. You're going to find some neat classic photos that other accounts have been posting, and one that we've been using as well so that you could find geology options later on. If that's a topic that you need to or want to cover, you can look for that Geology NCW. So we'd love to be continuing the chat with you even after the webinar closes. Now, when I first heard about the theme for this year's NCW, I got to say my first reaction was not, all right, but it was more like, all right. And the next question for myself was, what do I know about geology? Because I have to admit, I'm pretty limited in that area of the sciences. But as Michael showed, I think a great thing for us to do as teachers, and if we're doing outreach, instead of saying, well, what do or don't I know about geology, is rather to focus on the chemistry that's in connection with the geology, to say, you know, what are the topics I can cover? So Michael pointed out some of those in that poll that was so positive. We could see that there were chemical formulas, structures. He talked about visible spectrum, salt crystals, and solubility. So there's still big connection to chemistry, even if geology is not your specialty. Now, some of the other ACS resources that we want to share, this is one of my favorites. I always love to go back and look at the previous year's winners. ACS has typically offered a contest annually, and for the past several years, it's been an illustrated poem contest. I've selected one of my personal favorites, and we have a link for past winners from last year that I've included in the bibliography. And Lila was a student who shared one. Last year's theme was forensics, so you can see she did some fingerprints to go along with her poem there. Now, if you'd like to get involved in that poem contest with your students, the first step is going to be to contact your ACS local section and their NCW coordinator to look for deadlines for your particular local section area. And in just a second, I'm going to give you a reminder. David's already shared the link in the chat box, but I'm going to give you a reminder about how you can find that person and connect. And the poetry contest is open to students in K through 12, and they limit it, it's any type of poetry, but typically no more than 40 words, and local section winners go on to additional levels of the contest. So it's really a great interdisciplinary opportunity. I mean, you can combine art, writing, science. You could bring together teachers who are in your district to maybe collaborate on a project like that. Now, this is the link that David shared earlier in the chat box, but we've got the link down there. If you don't know who your National Chemistry Week coordinator is, if you're not directly connected, attending local section meetings, or if you don't even know at this time who your ACS local section is, because you don't need to be a member of it, of the local section or ACS, for your students to participate in this contest. They would just love to have you connect to the local section. Now, I guess what I'd like to do is a little bit of informal poll here, and Ruth has just put the link in there. If you know who your ACS local section is, I would love you to share the name of that in your chat box. And I see that some other people have even shared the link to their specific local section site. So if you already know who your ACS local section is, type that into the chat box. I'm going to enter mine. So I'm the Portland local section. So I know where mine is. So if you do know where yours is, we'd love to have you enter that. Now, if you don't know where it is, you could even click into that link that Ruth has posted already and do a quick check there, because if you just pop in your zip code, it'll tell you in the header where your local section is. And then you can get the name of your NCW coordinator, can click on that directly to email them and let them know that you're interested in hooking up with them for some NCW events and resources. Now, food is a really popular way that you could build interest in a topic, and I know it's been even the entire subject of past NCWs. But here's a question. Is it possible to connect rocks and cake, hopefully not through the actual final product of the baking to be like rocks, but we found a site that, and I got to say, the Great British Bake Off show, the baking show, is one of my favorite shows, possibly you or maybe some of your students. And so the Geological Society of London actually kind of started this jumping off from that particular sort of contest, and they started it 3 years ago, and it's called the Great Geo Bake Off. And the point of it is to model science with food and to model geology specifically with food. So they have participants, they offer them 10 specific categories each year. And the goal of almost each one, I'm going to say not every single one, is to represent geology-based formations, but they tend to throw some other ones in there. They're big fans of Jurassic Park. They had a Jurassic Park category a couple of years. They had Mordor for Lord of the Ring fans. So they just had many different options for really people of all ages to just get in there. And examples of the photos on the page there, you can see the geode on the left. So one of the 2017 categories was to try to model a geode in baking. The one on the right is another 2017 category for the contest, and that particular category was just Yellowstone. And so they wanted them to come up with that in cake. And I added that planet in the middle because we've added kind of a bonus link in the bibliography. There's a link that I found where it's about how to make scientifically accurate cake planets. So you're actually trying to get them spherical cakes in that chance. So this could be a possibility. It's definitely a higher energy and time requirement for this, but it could be maybe an outreach contest. And the point with this is also to connect the idea of models. How best can you portray key science ideas or structures? Now, along with the idea of modeling, we have another idea, and actually Sally's at the webinar right now, Sally Mitchell, and we've highlighted one of her tweets. She was recently at the ACS National Meeting in Washington, D.C. at the high school day, and the ACS Chem Clubs brought along one of the activities, and we've included this activity in your bibliography and resource packet. So you'll have the PDF that you would hand directly out to students if you wanted to try this activity with them, or this would also be a great one to use if you're doing like an outreach booth for an NCW celebration. So for this one, to model soil profiles, the handout itself talks about what each soil horizon, and those are the pieces that are labeled there with the capital letters O, A, B, C, and one that's not shown on this particular diagram is R, that would be bedrock underneath. But we asked students in the handout, how would you show those properties using food items? And it's really open-ended. You can have prepackaged foods. I know Karen, who ran this activity at the high school day, basically brought with her an entire suitcase of cookies and prepackaged pudding and different things that they could use to model it. But the point is to justify the choices that they made in the model. If they put, for example, crushed cookies at the bottom to show bedrock, how does that match up with the properties of the bedrock so that it links to what they're seeing in the model that they've created? Or, you know, where does the model fall down? At what point are we too limited to not link it with the science anymore? So you'll have that one. For the PDF, you'll have that directly, and I've included another link, and that'll be in the bibliography at the end. That's that chimus.com post, because David Katz has some other excellent ideas for modeling. For example, he does kind of a core of the earth model that he has where you've got a red hot cinnamon candy in the middle, and then you mold various pieces around that. So that's another option. Now, if you're still up with the food, you could also take it to the rock cycle. Now this one, we're not going to watch the video specifically because it's fairly long, but this could be an idea. I've done this with younger students at the school where I'm an ACS science coach, and so this might be an option to work with younger students, or maybe if you want to do it at an outreach event. So students are probably familiar with, this is about the main geology knowledge that I have left over from childhood, are the three types of rocks. You've got igneous, sedimentary, and metamorphic. And you can model the processes of those formations using starburst candy, which I'm showing on the screen right here. So for example, they start with sedimentary in the video, so he chops them up, basically cuts them up with the scissors. And students can take those, and to keep hands from getting sticky, they do it in a plastic bag, and they can just press them together to show the compaction and that they start to kind of stick together. Can take that to metamorphic, heat up the rock in your, or the simulated rock of the pieces of the starburst candy in the plastic bag just by warming it up in your hands and then adding pressure. They suggest just with books on top. And to take it even further, to go igneous, additional heat, and they use a hot plate in a foil boat. Now that could be, if you are working with younger children, just a demonstration that you could show one of those. I've seen this done before with crayon shavings. I like this one a little bit better, having worked with both. I felt it was easier to work with the starburst, specifically because they were stickier, because the pieces held together a little bit better, and it wasn't quite so messy beyond the sticky hands, which we try to prevent with the plastic bag around that. So that's another option if you're still interested in modeling with food. Now, if you want to stay on the topic of the rock cycle, these take it a little bit deeper. So the Starburst Lab is really a simplistic view of the processes that would be used to form the three types of rocks. If you want to take that a little bit deeper, we've got two links here. So one is a neat little interactive computer simulation from the BBC Bite Size Science. and it combines the explanation with some simplified drawings of the structures. So instead of having elaborate chemical structures, it's just going to use some simpler language. So a little bit of chemistry vocabulary, talks about compounds, crystals, freezing and melting, talks about different temperatures, heating and cooling, but it gives students a little bit of time to interact with that, some little bits that they can do in that simulation. So a little bit higher level. Now if you wanted to take it to a slightly higher level than even that, there is a lab that can be done on paper, and it's really a concept map style activity that takes it a little bit more in depth. And that's from the Royal Society of Chemistry. And they suggest that for ages 11 through 14. It takes about 30 minutes to do it. And they're given products, not really in the chemistry sense, but they talk about things that get formed like magma or different kinds of rocks. And then they're supposed to connect them in the concept map using words for the processes that formed them. For example, melting, crystallization, which have that chemical flavor to them, and also things like weathering. So those are some other examples if you wanted to stay with the rock cycle idea. Now I see in the chat box there, Sally did have a photo of the Starburst lab too that was also done at the ACS High School Day and was able to see the igneous, the melting there as well. Now if you want to take it to further than food, further than computer simulations, there is another activity I suggest if you want to still focus on the rocks and some of the weathering. So there are some simple hands-on experiments. Some of them work with actual rocks, and other ones are just to suggest certain ideas that would happen with the rocks. And then in my particular example, it was perfect because it comes from the Oregon Agriculture in the Classroom site. Now I will warn you, if you do want to get a copy of this lab, you do need to sign up for a free account to get that, but they do have some other really neat resources that I was able to get in the mail from them. So I was happy to do that, to get a copy of the lab and other items as well. So this particular activity has 4th through 12th grades listed as the levels. And they do have specific next generation science standards and also Common Core standards connected with this one, if that's something that you need to be aware of and meeting at your school. So they break students into stations and have them do different simulations. For example, they might have the students rub rocks together to show what glaciation might have a result of. They sandpaper rock to show a quick version of wind erosion. Or they take it to chemical weathering, which more directly connects with our view on it for National Chemistry Week by putting, for example, vinegar on a calcium carbonate tablet. Okay, but then they take it even beyond the hands-on experiments, and they want students to link those ideas with actual formations. Now, in the case of this lab, they are formations that students would see in Oregon, so largely promoted to schools who are located in Oregon, but you could do pretty much the same thing. So for example, 2 of the things we would see here in Oregon are Haystack Rock, and it asks students to link that with the idea of water erosion, okay, and how that's affecting the compounds of the rock. And the one on the left there, Oregon Caves National Monument, connects that with the idea of acidic rainwater, and we'll talk about that in a couple of minutes when we get to a sinkhole discussion. But basically that slightly acidic rainwater eventually dissolves the surrounding marble and has produced some just amazing formations. Now, in connection with places where you could go, so these are places where I could get to in my own region. You know, some I definitely have to drive to get there. But the National Chemistry Week community event, they always pick something that they'd kind of like to unify what different groups could do in their own area. And one of their suggestions is really to decide where you could head in your own area, and I called it a rock and field trip. Some suggestions there rock collections, maybe at a local natural history or geology museum. Back when I was at University of Wisconsin-Madison, they had a lovely, little geology museum just tucked away in the Department of Geology, and it was a great place to just stop by and see some of that. Or think outside the box. What about a local glassmaker? Or what about a power plant that uses coal? So is there a way you could connect natural materials and how they get modified for our own use? Or maybe even when we were talking about soil, is there a master gardeners group or a community garden that you and your students could visit? And so if anybody has any ideas for what is great to do, and it looks like Amy had a suggestion for where she might be able to head. It looks like in Georgia there. So if you have anything that's fabulous in your own region that you'd like to share, or another outside the box idea. And Martin has a comment there about the geologic map, because really perfect example, and that's true of really where anyone is in their particular region, that we could focus on the chemistry under the feet. And that's what that other additional lab, for example, the one with the Oregon formations, really talks about how the chemicals can change to give us what we actually see. Now I'm going to jump to another poll question, similar to the one that Michael had. So some of the topics that we've been talking about in the section here: structure of solids, physical chemical processes, and quite a few of those food activities have had analysis and creation of models. So I'm going to turn it over to Ruth because she can give us a reminder about the clip art.
All right, thank you so much. So many of you have already started placing your clip art on the screen. Remember to do so. You want to click on the mountain and moon icon that's in the very bottom icon in the left-hand side of your slide screens, and you just want to place it and then release, and then that will set it. And I'll let you do that for, probably about 5 more seconds, and then I'll go ahead and lock those and turn everything back over to Erica. All right, I'm going to go ahead and lock those and remove your clip art privileges. It's all yours.
Thanks. So I think the great thing about these webinars and what Michael and I have been trying to do is really create kind of a smorgasbord. Smorgasbord of geology. You're not going to love everything that we do. You're not going to find that it fits into the environment that you're in. Maybe you're outreach. Maybe you're a chemistry club. Maybe you want to do it with elementary. Maybe you want to do it with high school. And so really we encourage you to kind of pick and choose. And that bibliography and resource document that you're going to see at the end is going to give you those resources that you can pick and choose. So we're going to jump to the next slide, which takes us to another question break, and I'm going to turn it back to Ruth.
All right, thank you so much. If you have a question for either of our presenters, please place that into the chat window at this time. We have time for 2 more questions, and then we'll go on with the rest of the web seminar. So there's a couple people typing, so I'll just wait a minute and see what they have to say. So we have a question that says, are you aware of any labs in which students test the chemical composition of minerals or even the types of minerals within an unknown rock sample?
I'm going to say in my research, I have not, but I'm going to ask Michael here. Michael, have you come across any of that in your research for the webinar? And if there is, I'd love to have a link to that.
I think most of the activities that I've seen have to do with the different cycles. Like there's a lab about the copper cycle where copper is taken through various oxidations and reductions where it's turned into an oxide and then into a carbonate. It goes through a number of different reactions in a sequence, and then eventually gets back to elemental copper. I think those are the main sorts of things, and the other ones I've seen have been where there's sort of a percent composition done, where you reduce a metal out of one of its oxide forms or one of its oxidized forms, and you get an idea of the percent composition of it. But yeah, it's a good question. It'd be nice if there was something that was more comprehensive for the analysis of a mineral.
Wonderful. Thank you so much. So Valerie also has a question. How do you join the ACS Chem Club? Can you address that, Erica?
Sure. If you would like to join it, and it is a free program, as Marta mentioned earlier in the chat box, and the place where you want to go is, I should probably type it in, it is www.acs.org/chemclub. And that is the home page for the program. And if you go there, you're going to see a button toward the top that's called Start a Club. And if you click on Start a Club, you'll see in there it has another button that says Apply Now. And basically that's just to share your information with the staff. And for this particular one, you do not have to be a member of the ACS or a local section to apply for the Chem Club program. And it is free to join, and that's about all you need to do. Marta has been a part of that program. Karen Kalawati, who is currently on vacation, would be the one that you're going to correspond with, but it's super easy to do, and I know we have some advisors who have attended the webinar here, and they could also chat with you about that as well. So that's where you can go.
There's one more question. Let me see if I can get this. Lily wanted to know, regarding the lab and activities to determine chemical composition, one of our online activities is for NCW 2017 is Fizzy Fun. Where do you use the acid test to say if a given sample has or doesn't have calcium carbonate?
So I think for that one, and Lily, correct me if I'm wrong, but you're sharing that link as another opportunity. I think that kind of speaks back to where we were asking if there was really any lab that we could test, or see a reaction for a particular mineral. So I think that would be kind of a lower level resource opportunity, offering that as a resource for that. And let's see, Prem is asking about a similar program for middle schools. If you do have a middle school with the Chem Clubs, you can email Karen Kalawati, because I think it's done on kind of a case-by-case basis. There is no specific Chem Club program arranged for middle schools. I do know, and I have used the excellent middle school chemistry curriculum that the ACS offers, which is also free, and I'll put the link for that in. But you could email Karen to ask her about middle school clubs.
All right, thank you so much, Erica. It looks like those are all the questions at this time. If you want to go ahead and move on, we can.
All right. Thanks, Erica. That was a great section of activities. And I'll add my endorsement to ACS Chem Clubs. Everybody who is a chemistry teacher really needs to sign up to have a club. It's a very open-ended program. You can do a lot, you can do a little, but just getting the resources is worth the price of admission, which is free. But you definitely ought to do it. And I think it'll give you great encouragement to have interactions with kids in your classroom and as an after-school kind of activity. I just wanted to share a couple of quick simulations that I thought were pretty nice. This one is Volcano in a Cup. It's from C. Spangler. It is a nice little demonstration of how lava eruptions can happen. And I really liked it because it's a little bit more authentic than a lot of the volcano reactions. The whole idea of putting acid in, baking soda in some sort of clay volcano is okay. It's fun, it's dramatic, but it doesn't have as much to do. It's not as close to modeling the real activities as you might think, but I think this one does. So the way this works is I'm going to turn it over to Ruth. She'll give you a link, and you'll watch this on your home computer. We'll give you a bit to watch it, and then we'll summarize it as you come back.
All right. Thank you very much, Michael. So I've put the link in the chat, and this is 1 minute and 3 seconds. So I'm going to start the timer for 1 minute 30 seconds. That'll give you guys time to get everything loaded. And when the timer goes off, come back and we'll continue with our program. All right, so the timer means that it's time to come back to the program. And Michael, tell us what you want us to do next.
Well, I hope you're able to see that. I think it's a pretty good model for showing how superheated lava flows to the surface and can go across the surface as a superheated liquid. I think it does have the advantage that it's a little bit more authentic than some of the other typical kind of volcanic simulations that we do in classrooms. And I think it opens up for some questions. I think maybe it's a little inauthentic in that the reason that the wax is going up to the surface of the water has to do with density. I'm not quite convinced that that's the way that it really works in lava eruptions as they happen in real life. But nonetheless, it's a good place to talk about the departure of how the model represents real life and how it doesn't. This is one more video that I think is just really spectacular. It is an area in Hawaii where there is this actual event happening where there's a USGS scientist who's sampling lava. So let me ask you to take a look at this one as well. And then there's a couple of lessons about it that I'd like to talk about just after we watch the video. So I'll turn it back over to Ruth.
All right, thank you so much, Michael. This video is 1 minute and 17 seconds. I'm going to go ahead and give you 1 minute 30 again. And when the timer goes off, come back and let's talk about it. All right, if I could have everyone come back to the web seminar now. Michael, tell us more about this video.
The great thing I liked about this is the whole idea about states of matter. And I think our students sometimes have misconceptions about states of matter. They sort of think water is a liquid and the air is a gas and rock is a solid. And it's sort of difficult for kids to get the idea that most kinds of matter can be either a solid or a liquid or a gas depending on the temperature and pressure that they're at. So gold can be a gas. Carbon dioxide can be a solid. Rock can be a liquid. And the whole idea of showing molten rock in this sort of vivid way is a good example to maybe open that discussion. The other thing I liked about it was just the amazing specific heat capacity of the molten rock. You might have noticed that when it's put in that tub of room temperature water that it boils very rapidly. So there's another great transition there that's interesting in pointing out. And you might even point out that ancient civilizations, when they had containers for water that weren't suitable for heating on top of a flame, would use this to boil water. They'd put in, not lava, but rocks that had been heated in a fire in order to get the water up to boiling temperature. All right, with that, I'm going to the next slide and turn it over to Erica.
Thanks, Michael. So Chem Matters has already come up in conversation earlier in the webinar in relation to some articles that might be good resources. And I want to highlight one of those, and you can see the title there, Sinkholes, Chemistry Goes Deep. This was from 3 years ago, and Ruth has just put up a link for that. This is one of the freely available articles through Chem Matters. And you can see one of the photos that I have pulled from that particular article of a sinkhole opening up in a road and basically swallowing a car. You can see, you know, for scale, there are people standing next to it and gazing in on their bicycles. So the article, I'm not going to dwell a lot on the chemistry here because the article explains it so well. So the article's in there about 2 to 3 pages long, and it really summarizes excellently the causes of sinkholes, which can include human activity, could include pressure, and then really gets into the acid-base chemistry, particularly of limestone. So if you've ever heard of Sinkhole Alley, over there in Florida, so most of what's underfoot there, they've got a lot of limestone there, and the effect of slightly acidified rainfall, which just happens naturally as water comes in contact with the carbon dioxide in the air, and also from any decaying organic material that you're going to find in the soil. It's going to slightly acidify that water, and as it interacts over time with the limestone underneath, it's going to eat away holes and can have that devastating effect if there are people living there. Now, in connection with that, you can do a brief activity with students, or it could be a demonstration. This is one that we had included in a Chem Club packet that we sent out last spring to get clubs ready for National Chemistry Week the following fall. So Ruth has included a couple references that you'll see in the bibliography there that we used as resources for that. So students create a sinkhole, and it's just, you start out with a little tube that you've made of a rolled up Post-it note, and you fill that almost all the way with just table sugar, sucrose, and surround it with sand, and then pull out your tube and cover that with a little bit more sand. Now, before you do that, you have a hole in the bottom of your cup that you've covered up with a little cutout piece of a kitchen scrubby, like a green one, so that we can get water filtering through there. Now, you can see I added my simulated houses. They're just little base 10 blocks I've got at home. So once you put the cup itself with that hole in the bottom in a container of water, the sugar dissolves in the water very quickly, which you can see one of my fake houses has fallen into that sinkhole created by the sugar dissolving in water. Now, that dissolving is not the same as the acid-base chemistry that you would see in a true sinkhole, but instead you could talk about dissolution, about what the sugar does when it meets the water. But Michael did have another suggestion for an extension when we were chatting about the webinar, which we haven't tried, but I think would be neat if somebody would, to maybe try an extension where instead of sugar and water, if you use powdered chalk in the sand and used vinegar as your liquid, but that could bring in another acid-base connection there. Now, another piece, and instead of going to the video, if you do go to that later on your own, you can see some recent aftermath of Hurricane Irma, and you can see in that still shot there that a sinkhole has opened up behind a middle school, and it extends for quite some time. They show a little bit of a aerial visual shot in there. So you can see the real life destruction, the damage people have occasionally died from sinkholes, but truly can be devastating. Now, to also connect, since limestone plays such a large role with the sinkholes, could also connect that back to students' everyday lives. Now, there's another activity that we've linked to here, which asks students to kind of keep, log their activities for a day, and this is for older students, more of the high school age, and asks for them to research how limestone plays a role in different parts of their lives. So, for example, they take a hot shower in the morning, the water is stored behind concrete dams, talks about how limestone is used in cement and concrete. They use a sink to wash their hands, can talk about how the tiles behind it and the sink itself. Ceramics are made from clay, sand, small amounts of limestone in the glazes, another opportunity. Or even, and this was new to me when I was looking at the activity, carpet backing. Limestone is actually used as a filler to extend the latex, since the latex is more expensive, and then just kind of bulk it out in the carpet for less expensive material. So Michael's actually going to wrap us up with a few more activities, and for this he's going to head underwater.
Thanks, Erica. Yeah, I think when most of us think about geology, we sort of think about dry land geology and rocks and minerals. But there's an important field of marine geochemistry that's very critical to all life on Earth. And one of the things I wanted to talk about is some of the interactions with carbon dioxide, because it has some profound implications for us right now. You may very well have studied this, and this is relatively sophisticated chemistry. We're really talking about chemical equilibria as carbon dioxide dissolves in water, both fresh waters and in our oceans. But in equation 1, you basically see what happens when gaseous carbon dioxide dissolves in water to make aqueous CO2. This is a process that is increasing as carbon dioxide increases in its mole fraction in the atmosphere. It's going to drive this equilibrium to the right, so we get more carbon dioxide aqueous that's dissolved. The equilibrium in water is pretty straightforward. The CO2 reacts with water to form carbonic acid. But carbonic acid is very unstable, and it almost immediately dissociates into a hydrogen ion and a bicarbonate ion. In fact, most of the carbon dioxide in our oceans exists in this form, something like 89%. Because the second Ka, the subsequent dissociation is harder because the hydrogen is held on all the more tightly. So getting down to a straight carbonate ion with an additional ionized hydrogen ion is more difficult. So only about 10% of the carbon dioxide exists in this form. But the punchline in all of this is really what happens to the equilibrium on the bottom. This is an important marine reaction that is important in all shellfish. Anything that uses the calcium ions that are present in seawater to form their shells in the form of a solid calcium carbonate is dependent on this reaction. But if we go back to Le Chatelier's principle and you look at this equation, think about the equilibrium shift if the carbon dioxide on the right-hand side, the aqueous carbon dioxide concentration increases. It shifts this equilibrium to the left, and that can have devastating results for shellfish populations. I know in the Pacific Northwest there's been considerable studies on oysters and other shellfish where particularly the larval form of these species is having a very difficult time creating and maintaining shells. So despite skeptics, this is pretty straightforward chemistry and a demonstrated effect that doesn't particularly have to do with any kind of debate or argumentation. This is really just a straightforward application of basic chemical concepts, and an important one, I think, for us to share with our students. And the last slide I wanted to share is a clever activity I got from the Royal Society of Chemistry in England. The whole idea that we study matter and we talk about the kinds of elements and compounds that are present, but the truth is almost everything we study comes out of a jar. And it kind of reminds me of the old joke about what 3 sources of protein are from meats in nature. And the kid answers Albertsons, Kroger's, and Safeway. The whole idea that the only way they can imagine food coming to them is through the grocery store. And the same may be for us, but really when you think about the study of geology and geochemistry in our classes, that's the source of it all. That's where everything that we deal with, all of the manifold compounds that we use for materials for construction and for nutrition, all come from raw materials in nature. So I think it's always really fun to be able to show how elemental substances, which are almost all present in combined forms, can actually be squeezed out of their forms in ore. And this one is just really nice because it's so simple. The whole idea is just to char the point of a wood match and moisten it with a little bit of water and then rub some sodium carbonate crystals on it. And then rub the point in some iron 3 oxide and then put it into a flame. And the idea is that this is suitable conditions to reduce the iron oxide into elemental iron. And the whole idea is that once this reaction does happen, then the proof is to test it with a magnet. And you can see that there's actually some magnetic particles that will adhere, where in the previous form, the iron 3 oxide will not be attracted to the magnet. So for little investment in time or materials, I think it's just a really nice way, kind of getting back to the suggestion that was done earlier about how can you kind of demonstrate an analysis of some oxides or minerals. I think this is a really nice way to do one kind of activity like that. So with that, basically ends the kinds of things that we had to present to you, and I'll turn the presentation back over to Ruth.
Thank you, Michael. I'm going to paste the link for the collection that's in the Learning Center in the chat. So that has all of the resources that were shared tonight and any of the videos and other articles. So you can go ahead and go to that and see those resources, which were just amazing. Thank you so much for sharing tonight. I would like to thank Michael Tennesand and Erica Jacobson for sharing with us tonight. I think they did a wonderful job. I'd also like to thank our sponsor tonight, the American Chemical Society. And finally, I'd really like to extend my thanks to the administration of the National Science Teachers Association for their continued support of web seminars.